Okay, guys, so let's say I want to find the reference angle for 580, this angle right here, the non-acute angle 580. Now, one thing to know is that whenever we say reference angles, what we mean is, let's say for example you had an angle right here. So starting from here, let's say the reference angle, the terminal side is right here, okay, for this angle. So when we say reference angle, what we mean is that you need an angle formed. We're talking about the angle, let's say if I call it x, formed by the terminal side and the x-axis, okay, by the terminal side and the x-axis. Okay, so that's what we're talking about when we say acute angle. So in this case, that would be x, okay? It would be x. Okay, so now let's solve this one here. We have 580, right? So if it's 580, what we need to know, first of all, it's 580. That's way more than the full circle, okay? So we know that we will have to subtract 360 to know exactly what it is, because 580 is more than a full circle. So first thing I'll do 580 minus 360, right? 580 minus 360 degrees. And in this case here, it will be 220, right? 220 degrees. So 220 degrees, we know where that is. So we can actually draw this just to see exactly where it is. So we have X here, Y here, and we have 220. So remember, this part is 180. So 220 obviously will be somewhere here. The terminal side will be somewhere here. But 220, we can do 180 minus 220, 220 minus 180 to get the actual reference angle we're going to get here. Because 180 is right here, okay? If we know it's 220, it's 20 more than 20 again, making it what? 220. Okay, so that's 40 more. Okay, so you can do it this way, or you can just say, okay, if it's 220, it's right here. I need to subtract from 180. So let's do 220, 180 subtracted from 220 to get this actual angle we need. In this case, it would be 40, right? As we just said, 40 degrees. So we know this side here, this angle right here, if we call it theta, it will be 40 degrees. Okay, so 40 degrees right here. We know that it's the angle formed by the terminal side and the x-axis. Okay, so that's why we know this is actually the reference angle. Theta equals to 40. So this is the reference angle. Okay, as you can see. All right, now let's say we have another one here. Let's try another one. Let's say, what if we have something written like this now, like 8 pi over 3, for example. 8 pi over 3. Now, if it's 8 pi over 3, guys, so what you do, first of all, this is 8 over 3. So you see 8 pi, that means it's as if you have many, because in your mind, you know 2 pi is one full circle, right? So that's 2 pi, one full circle. Now, if you have 8 pi over 3, one thing you could do, you could try to divide to see if you will still have 2 pi when you divide. Now, some people would just do 3 by 8, or, you know, using your calculator, and you'll see if you have 2 point something or 2 whatever. Now, in this case, as you can see, seems like you're going to get something like that, right? So that means it's more than 2 pi. If it's more than 2 pi, you just need to subtract 2 pi from it, right? Just like I subtracted 360 from 580. So you're going to do, because this is in radians, okay? So I'll do 8 pi over 3 minus 2 pi, just to have a better idea of the angle I have, okay? Now, once you do that, you'll have what? LCD here is 3. So I'm going to try to get 3 right here. because this was 1, so I'm going to multiply by 3 to get the same denominator here, because remember, it's a fraction. Therefore, I multiply the top by 3 as well. And what do I have? 8 pi over 3. So 8 pi minus 6 pi. 2 times 3, 6. 6 pi. So this will become what? 2 pi over 3. Okay? So 2 pi over 3. All right? This, you can actually draw it, or you know, whatever you want really, but you can actually draw this to see what it is. Now pi over 3 is actually, if you want, you can convert into degrees, so it could make more sense to you, but you don't have to. You just need to know what angle we're talking about here. Okay, so if you draw something, let's say just like we did last time, so we know pi over 3 is pretty much 60, so that'll be somewhere here, pi over 3. Now remember, it's 2 pi over 3 now, 2 times that. So if this is 60, I'm just saying it so you could see, pi over 3 is right here. Now another 60, because the total is 90, another 60 will have to get another 30 right here, so like right here. Okay, so 2 pi over 3 will be right here. So this is the terminal side of that angle. Okay, now what do we say? We need the reference angle. How do we get a reference angle? Guess what? The reference angle, we get it by identifying the angle formed by the terminal side and the x-axis, right? As in this case here, the angle we need will be right here. All right, so most of you already see what it's gonna be, because if this is right there and this part was 60, so this part will be, this part was 30 by itself, so this one will be 60. Okay, so then it will be pi over 3. But another way to get it is by subtracting. So since you have 2 pi over 3, you can do can do right here pi, because the total here is pi. Okay, so if you need to know what this is, you can just subtract this part right here from it. Let's say this right here was the non-acute angle. So to get this one, if I call it x, so to get this one, you just need to subtract this from the total, which is pi. So it will be 2 pi over 3, and the total is pi, so you subtract that from pi to get this part right here, theta. Okay, in this case, again, the same way, LCD is 3, so this will be 3 pi minus 2 pi over 3, which is 3 pi minus 2 pi is pi over 3. So this is it right here, you know, theta is pi over 3. Okay, so this is how you get reference angles. So not difficult at all for you to do. You just need to make sure you look for what you need. Make sure you draw the coordinate plane just like I did here, and then it will be pretty easy for you guys to identify which quadrant and what to subtract or add to get the angle you need. Okay, so this is how you get reference angles. And remember, the reference angles, they're actually formed with the terminal side of the angle and the x-axis. So the angle formed by the terminal side and the x-axis. Okay, thank you.